And, oh, I'm a little off here. Hold on. There we go. So, Okay, so I can see one noticeably. Does everybody see I can see one noticeably? This one right here? Yes? What's that coordinate? Negative 1, 2, 3, 4, negative 3. What's the other one? It would be 4, 8, yes. Okay, so let's do 4, 8. Do you know why it's 4, 8 instead of 4, 16? It's half the amount, right? So we're going to go 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. So it actually does go right through that point there. So what is that? 2, 3. Okay, so had a little bit of trouble knowing what that one point is, so there's got to be a better way. What's the better way? Doing some algebra. Okay, so back in the day, grade 10, you learned how to solve systems of lines algebraically using the elimination or the substitution method. So when we have y equals 1/2 x squared plus 2x minus 3, and y minus x minus 1 equals 0, elimination doesn't really work that great unless you have them all lined up in order to add or subtract. So the best way, even though when you were solving lines last year, you probably liked the elimination method. Did you call it this addition method or elimination? Can't remember. When you added them, something eliminated. Anyways, for these ones, when you have a line and a parabola, it's much easier to do substitution because a lot of the times it's already solved for a variable. Do you see it's solved for a variable here? Y equals that, right? So that means I can substitute that y for that whole string. Do you see that? So I'm going to use substitution. So instead of this y, I'm going to write 1/2 x squared plus 2x minus 3, but I still have the rest of this string I need to put in, right? So subtract x, subtract 1 equals 0. Does everybody know what I did there? Maybe I'll do color coding. I substituted this for the y right here. That's what that was. Does everybody see? Okay, so now how do I solve this? What is this considered? It's a quadratic. So the first thing I should have is equals 0 on the one side, which I do. The next thing, I need to simplify stuff. So I have a 1/2 x squared, a 2x and a minus x gives me a plus x, a minus 3 and a minus 1 gives me a minus 4 equals 0. Now, normally we would always try to factor. That's our go-to thing, right? We don't want to use the quadratic formula or completing square. However, I don't like fractions. So what was the little trick that we learned before we started so we don't have to do fractions? A little magic multiplier. Huh? Multiply each and every one by 2. Get rid of the, yes? So if I multiply this by 2, I get x squared. If I multiply this by 2, I get 2x. If I multiply this by 2, I get 8. And if I multiply 0 by 2, I get 0 still. Does everybody see what I did? I multiplied by LCD. We used to call it the magic multiplier, coined by a colleague of ours. Multiplied by LCD to get rid of fraction. Okay, can this factor? Okay, so we're going to factor this. So we get x plus 4, x minus 2 equals 0. Don't forget the equals 0. So then what does x equal? Negative 4 and positive 2. Does everybody see what that represents in my graph? I said x equals -4 and 2. Does everybody see where that is? Now, how am I going to get the y result? Yeah, you plug it back in. Do you remember doing this now from grade 10? Once you solve one, then you plug it back in to get the others. So you'll have to plug in 2 because, again, whatever we get as a solution is a point of intersection, right? So you can't just stop at x equals -4 and 2 because it doesn't tell me the height of where they're intersecting. So we're going to sub it back into probably I don't know, which one's the easiest one? Well, we can put it up here and it tells you y exactly, or you can put it right here and then only deal with whole numbers. It's up to you. It doesn't matter. You like whole numbers? Okay, so I'm going to substitute it into the second one just because I don't like the fractions. So I get y subtract -4 minus 1 equals 0. Does everybody see what I did there? So then y plus 4 minus 1 equals 0. What's plus 4 minus 1? Plus 3. So y plus 3 equals 0. So do you see I get y equals -3? And that's exactly what I should have got. Right there, -3, yes. And then if I substitute 2 in, I'm running out of room, so I'm gonna go up here then. So y minus 2 minus 1 equals 0. Y minus 3 equals 0. Y equals 3. So does everybody see? When I substitute 2 in, I get 3. Whatever I get graphically, I should get the same algebraically. We're just doing it a different method. Does that make sense to you? Okay. So, do you guys want to try the next one? Now this is 2 parabolas. 2 parabolas, yes. Okay, so what do we have to do first? Yeah, we have to factor out a 3, and we're left with x squared plus 4x, leave a space, plus 6, yes? I'm completing the square to get the vertex, yes? Then we get, I didn't give you enough room to complete the square here, 3 bracket x plus 2 squared. If I square 2, what do I get? 4. And really, what did I do there? I added 12. So what do I have to do to compensate? Subtract 12, so I get a -6. So my vertex is at what? -2, -6. So 1, 2, 1, 2, 3, 4, 5, 6. There's my vertex. And the pattern of 0, 0, 1, 1, 2, 4 becomes 1, 3, 1, 1, 2, 3. And instead of 2, 4, it's going to be 2, 12. 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then that's the same there. It's stretched, right? Yes? Okay, the next one. Oh, I don't have a lot of room here. So let's do it over here. Sure. I'll do it underneath the solution. Oops. Y equals -4. I'm going to factor out the -4. What am I left with? X squared plus 4x, leave a space, minus 15. So we're going to take half of 4, which is 2, and I'm going to square it, which is 4. So what did I really do here? I subtracted 16, which means I need to add 16, which means I get a +1. So my vertex is at what? -2, 1. -2, 1. And instead of a 0, 0, 1, 1, 2, 4, we're facing down and we're going 1, 4. 1, 2, 3, 4. Hey, look at that. Oh, we don't have to do any more. We have our point of intersection, don't we? So what is my solution? We've got -1, -3, and -3, -3. Yeah? Okay, let's do this algebraically. Algebraically, How do we do this? It's already solved for y. So we're going to take this y and substitute it into that y. Does everybody see what I'm doing? So I'll get negative 4x squared minus 16x minus 15 equals 3x squared plus 12x plus 6. Does everybody see what I did there? Okay, how do we solve this? How do we solve this? Move everything over because we need it equal 0 to do anything, right? So I'm thinking I'm going to move this over to the right. Why do I want to do that? Yeah, I want to deal with positive instead of negative. So 0 equals 7x squared plus 28x plus 21. Before I even start to factor, there's a GCF I can get rid of. A 7. 0 equals x squared plus 4x plus 3. Isn't that much easier to solve? Why can I do what I did? I just divided the 7 out of there. That's right. Whatever I did to one side, I did to the other. This is not an expression where I only have one side. I actually have a left side and a right side. So what I did from this step to this step is I divided by 7 to both sides. And 0 divided by 7 is 0, right? So we're going to solve this. Don't drop the equals 0. This is x plus 3, x plus 1. So that means x equals negative 3 and negative 1. Hey, look at that. Okay, we're not done yet. We got to find out what our y is algebraically. So it doesn't matter which one you pick. Pick one of them. You have no room. Sorry about that. Y equals 3, negative 3 squared plus 12 times negative 3 plus 6. Negative 3 squared is 9. 9 times 3 is 27 minus 36 plus 6. Now, I could do it from left to right, but the nice thing about integers is you can do it in any order that makes more sense. And I kind of like doing minus 36 plus 6 because then I get minus 30, and then minus 30 and a 27 make a 3. Do you see how it was way easier to do that instead of trying to figure out what this minus this is plus 6? Yes? As long as you group the signs with it, then it's all good. No. Oh, yes, you are absolutely right. Minus 3. Minus 3. And that's what I got there, right? Minus 3. Okay, let's do it for the minus 1. 3 times minus 1 squared plus 12 times minus 1 plus 6. So we get 3 minus 12 plus 6. Sometimes I like actually doing the positives together. So 3 and 6 is 9. 9 minus 12 is minus 3, which I should have got, right? So do you see this is my solution here? Yeah? Okay, looks like we have to do one more graph. Okay, try this one. This one's an easy one to graph. Yes? Okay, so this is a parabola that's up 2. And then we have a line. So that's minus 3, 1, 2, 3, up 1 over 1, up 1 over 1. And it looks like, oh my gosh, I think I need a ruler. Okay, so there's my line. Visually, you can see these will never intersect. And what did we learn last year when they never intersect? No solution. Okay, so now algebraically, we want to come up with something that we'll know when we find it algebraically that there's no solution. So we are subbing in to the y there. So I get x squared plus 2 equals x minus 3. Move everything over. X squared minus x minus 5 equals 0. And this factor. No, that does not mean it's no solution. You have to go and prove that there's no solution by doing discriminant. We're hoping that the discriminant will be what? Negative. You got to show the discriminant is negative to conclude that it's no solution. So b is -1, so that would be -1 squared. And some people are still getting this wrong. It's b squared minus 4ac. It should be a positive 5. Sorry. Yeah, sorry about that. So b squared minus 4ac, right? So subtract 4 times 1 times 5. So then I get 1 minus 20 gives me -19. Therefore, what can I conclude? No solution. Let's try example 2. So one of the benefits of solving algebraically is sometimes when you graphic, they don't, like I've only been picking ones that have like whole number points, right? So you can read it. And on the test, I'll try to be nice and make sure they're whole number points as well. Algebraically, it can be anything, right? So I'll give you a forewarning. This example, you will not get nice little answers. Yes, but we're going to leave them as exact values, okay? So, how are we going to solve this? Which is the easiest thing to do here?
Isolate y.
Isolate y. Probably in this one, right? For both of them. Actually, I kind of like that thinking. Let's isolate y for both of them. So we get y equals 2x squared plus 4x minus 3. And I'm going to isolate y on this one. I'm just going to move that y over. Okay, I'm moving the y over to the other side. So y equals 3x squared plus 4x minus 8. Does everybody see what I did? Okay, now that it's in both y equals, I'm going to substitute this y into that y. It's way easier. You'll make less mistakes that way. So 3x squared plus 4x minus 8 equals 2x squared plus 4x minus 3. Which way are we going to go? Left side to the left? Okay. So we get x squared. Oh, look at that. Minus 5 equals 0. That's not so bad though, hey? X squared equals 5. So what does x equal? Yes, don't forget the plus or minus. That's how we're going to get 2 solutions, right? If you just put the square root of 5, you're only going to get 1 solution. So now we need to plug her in. So which one do you want to plug it into? Well, I guess the first thing first, does everybody see that my solution is two answers here, right? It's going to be root 5 comma something and negative root 5 comma something. I just got to figure out what that something is. So do you see you're going to substitute root 5 in and negative root 5 to get what the y's are, right? Not this whole thing together. Yeah? Okay, so now when x equals root 5, which one do you want to sub it in? Doesn't matter, you'll get the same answer. The first one, okay. So 3 root 5, the whole thing squared, plus 4 root 5 minus y minus 8 equals 0. Does everybody see what I did there? Now hopefully by now you know what root 5 squared is. 5. 5 times 3 is 15 plus 4 root 5 minus y minus 8 equals 0. We good so far? Okay, I'm going to put the y on the other side and I'm going to combine the 15 and the minus 8. So 4 root 5, what's 15 minus 8? Plus 7 equals y. Okay, so when root 5 is in there, I don't have enough room to write this. I get 4 root 5 plus 7 as my coordinate. If I had a calculator, which you won't, if I had a calculator, it would actually go 4 times root 5 plus 7, and it would be approximately some decimal, right? Sure. It certainly would. Why do we shy away from that? Okay, so when x equals negative root 5, okay, let's finish this off. 3 times negative root 5 squared plus 4, sorry, I didn't write a 4. Plus 4 times negative root 5 minus y minus 8 equals 0. So what's negative root 5, the whole thing squared? Negative root 5 times negative root 5, what's that? Positive 5, yeah? Times 3 is 15. And then 4 times minus root 5 is minus 4 root 5. I'm going to move the y over to the other side, so minus 8 equals y. What's 15 minus 8? 7 minus 4 root 5 equals y. So I'm going to go 7 subtract 4 root 5. You can write it as 4 root 5. Sorry, negative 4 root 5 plus 7. You could have. I hesitate doing that because sometimes you make a mistake. Mind you, if you made a mistake at that point, you probably made a mistake of the whole thing. So, but yeah, we could have put it into this. Yes. Well, I know for the lines when we check our answers, I always say go back to the original because that'll truly tell you if you made a mistake graphing, right? Okay, let's try this one now. This one works nicely for whole numbers. Okay, so for elimination, what we do is we need to have one variable to eliminate, and I can see the y's are set up nicely to eliminate if I switch one of the equation signs. So if I switch this sign and get negative 3x squared plus x plus y plus 2 equals 0, and 6x squared plus 4x minus y minus 4 equals 0. Do you see if you add them now, the y's will eliminate? Plus y minus y. And so follow the signs here. Negative 3x squared and 6x squared gives me 3x squared plus 5x minus 2 equals 0. Just to show you the substitution method, you would have got the same thing. But you have to do a couple extra steps. You got to solve for y first. So y equals 3x squared minus x minus 2 equals, sorry, you wouldn't have equals 0. And then you'd have the other one, y equals 6x squared plus 4x minus 4. And you're going to substitute that into there. Do you see? So then you get 6x squared plus 4x minus 4 equals 3x squared minus x minus 2. If I move this all over, what do I get? 3x squared plus 5x minus 2 equals 0. Do you see you get the same, you get back to the same step. Just one is easy when it's nicely set up like that, right? Substitution works every single time, no matter if it's a line, but you know from grade 10, sometimes those lines have ugly fractions and stuff like that, and you don't want to do all that, right? So at this point in time, now we can solve a quadratic. So how do we solve a quadratic? Try to factor, right? So 3x and x, and I got to do a 2 and a 1. It looks like a plus 6 and a minus. Is that right? So then I get x equals 1/3 and minus 2. So I know I'm going to put my solution down here. Is going to be 1/3 comma something. I'm going to figure that out. And minus 2 comma something, and I'll figure that out. Okay. So we got to, huh? So I'm going to sub it in. So I'm going to sub it into the one that's already in the y equals form. So I'm going to go, when x equals 1/3, I get y equals 3 times 1/3 squared minus 1/3 minus 2. Does everybody see what I did? So yeah, fractions are a little harder to work with, but you should be able to do this. What's 1/3 squared? No. 1/9. What's 3 times 1/9? Well, you should never multiply and get 3 9s. You should cross cancel. What does this cross cancel to be? 1/3. So then we get 1/3 minus 1/3 minus 2. Hey, that's nice, hey? And what do we get as my final answer? Minus 2. So when it's 1/3, I get minus 2. Does everybody see what I did there? So when x is -2, we get 3 times -2 squared minus -2 minus 2. Ooh, that's a lot of -2's. Again, we do bed math. What's -2 squared? Positive 4. 4 times 3 is 12. Minus -2 is +2. And then I still have a -2. Hey, look at that. +2 minus 2. Bam, bam. What are we left with? 12. Now, bingo, bango. That's right. So, do you know you can verify your solutions get 100% on this test? If you have time, substitute this into both the equations and see if you get it. Okay? That's what it means by verifying your solutions. Both. Do you want me to do it just to show you? Okay. I don't have. How about I verify the last one, because I don't have very much room here. You just plug it in, and the left side has to equal the right side. We did that for the other ones, right? Okay. So what do you want to do here? Move the y's over. Okay, so y is going to equal 5x minus 10. Is everybody good with that? I moved the 10 over and the y over at the same time, and then I rewrote the y on the other side. You can handle that, right? Uh-oh. Yes. Okay, I'm not liking solving for y on this one. So now what can I do, though? I can just substitute this in for this y there. Does everybody see that? I don't need to solve for the y. This is what you learned in grade 10, right? So you get x squared plus x minus 2. Instead of the y, I'm going to write 5x minus 10 equals 0. Does everybody see what I did there? Yeah, so I need to multiply this in now. So I get x squared plus x minus 10x plus 20 equals 0. And then I get x squared minus 9x plus 20 equals 0. And yeah, x minus 5, x minus 4. So x equals 5 and 4. Yeah, it does. I'll try to be nice to you. Okay, so now what do we do? Well, it's got a nice y equals tone to it, so let's sub it into there, right? You could probably do that in mental math. What's my solution? 5, comma, 5 goes in there. 5 times 5 is 25. 25 minus 10 is 15. And 4 goes in there. 5 times 4 is 20. 20 minus 10 is 10. Okay, so now I'm going to show you how I'm verifying my solutions. This is how you guarantee yourself 100%. I need to substitute this coordinate into both, right? So I'm going to be checking this. So this is going to be, so this is the verify. Okay, so 5 goes in there. I get 5 times 5 minus 15. Does that equal 10? Does that equal 10? So that works. Now I'm going to substitute 5 in there. I get 5 squared plus 5 minus 2 times 15 equals 0. 5 squared. I have to do it into both to verify this point. 5 squared is 25. 25 plus 5 is 30. And what's minus 2 times 15? 30. Minus 30. So 30 minus 30 is 0. So this point worked. Now I got to check this point. So 5 times 4 minus 10, does that equal 10? Yes? Okay, now I'm going to substitute 410 into the second one. 4 squared plus 4 minus 2 times 10 equals 0. So this is 16 plus 4 is 20. 20 minus 20 is 0. So they both work. Do you see how I verified it? Okay.